Professor Odi Thapar, Mrs Alison Bartle, distinguished participants from different parts of the globe, faculty colleagues, and dear students. I welcome you all for this eminent lecture on hydropower, its role in socio-economic development, and its promise of sustainability for future. This lecture will be delivered by the speaker, Alison Bartle. Now, this lecture series was started on the initiative of Professor A.K. Chaturvedi, Director IIT Roorkee, in all the departments. And it was named in the eminent personalities who have significantly contributed for the departments. For our department, HRED, Department of Hydro and Renewable Energy, Professor Odi Thapar is the founding head of the department, who established the department in the year 1982 as AHEC, Alternate Hydro Energy Center. Professor Thapar originally hails from Lahore, and he obtained his bachelor's degree in mechanical and electrical engineering from IIT BHU in the year 1945. Then he joined Punjab State Electricity Board, and from there he moved to the prestigious projects of Bhakra and Byas hydro projects, managed by the organization BBMB, Bhakra and Byas Management Board. From BBMB, Professor Thapar moved to IIT Roorkee, that time it was University of Roorkee, in the year 1974 in the Department of Water Resources. In late 70s, Professor Thapar started working in the field of small hydropower and hybrid energy. And from that, he was successful in establishing AHEC in the year 1982 with the support of Ministry of New and Renewable Energy. Professor Thapar led the department till his retirement in 1986. Under his leadership, AHEC completed several small hydropower projects in the state of Haryana, Himachal Pradesh, and Uttarakhand, from concept to commissioning, where all the person need to work hard for all the data collection, investigations, planning, design, even support in execution. And from that, we received the direction of research for solving the actual field problems. Based on his professional experience, Professor Thapar wrote a book on modernization of hydroelectric engineering practice. This book was released in 2013 and it is freely available on our department's website. The center, named as Alternate Hydrogen Center, initiated by Professor Odi Thapar in the year 1982, has now become Department of Hydro and Renewable Energy. And at present, we have 11 faculty drawn from multidisciplinary areas working in the field of hydropower, all renewable energy sources, and environmental aspect of water bodies. The contribution of Professor Thapar is immense for HRED as well as for hydropower. Now, on this occasion, I also feel pleasure in announcing that the family of Professor Thapar is offering rupees 25 lakhs to the endowment fund to sponsor this event on perpetual basis. We are thankful to them. Incidentally, Dr. Rakesh Thapar, son of Professor Thapar, and Dr. Vandana Thapar, his daughter, both are our alumnus, and they have joined the event. Now, I request to Professor Odi Thapar to bless us with his remarks. Sir Thapar, sir.
Mr. Allison, Professor Chaturvedi, Professor Singhal, colleagues, and friends. I'm grateful to IIT Roorkee for bestowing this honor to me. Energy crisis in the country erupted in March 1974 when I joined Roorkee University as a professor and at that time the oil prices were suddenly abnormally increased, and small-scale diesel power generation in rural and remote areas was quite common to meet power needs. It was also affected. Frantic search for alternative, compatible, cost-effective power generation started in the country. Accelerated efforts to develop available hydro energy sources for utilization for generation electricity using modern methods of design and control were initiated. It was noticed that large amount of energy is available in flowing canals, rivers, streams, and rapids near these remote load centers and could be harnessed for local power generation needs. Conventional hydropower generation requires large-scale water storage to meet load factor demand. Hydro is a valuable energy resource and optimum utilization of such resources is required. Management and capital costs are prohibitive and not easily possible. The basis for development of hydropower projects is to be modified and evolved, and that hydropower projects are developed as alternate source of energy. Maximum possible hydro energy will evolve into electricity. It is a clean source of energy. Thank you. I'm thankful to Ms. Alison for delivering this lecture today. My best wishes and blessings to her. My heartfelt thanks to IIT Roorkee for giving me this honor. Thank you.
And thank you, sir. Professor Arun Kumar.
Thank you, Professor Sunil Singhal. Now it's my pleasure to introduce you today's speaker, Mrs. Alison Bartle. Mrs. Alison Bartle is a very well-known who is writing, editing, publishing, and presenting in the field of water resources development for more than 4 decades. She is the director of Aqua Media International and publisher, editor of the most reputed journal called International Journal of Hydropower Dams. Mr. Alison is an honorary member of ICOLD and was founder of IHA for Dr. Emil Mossoni, another stalwart in the hydro in 1995, and a member of board for 10 years. She served on ICOLD, that's called International Commission on Large Dams, Public Awareness Committee for 20 years, and currently she is on the governing committee for its 4-year mandate. She is currently member of ICOLD Committee on Resettlement. She is also on advisory board of European Union supported IOPSO hydro solution projects. Alison is writing and presented papers on the role and benefits of hydropower and water sources schemes at many international events, including World Bank Forum in Washington, World Water Forum in Mexico, UN conference in inland navigation in Braklo and Sincol Corporation in Kunming. She was the winner of Turkish Prime Minister's Water Prize for the communication category in 2009, and she has been 2 times awardee of India Power in 2009-2010. Along with her team, she organizes large annual international conferences in Europe on hydropower and water infrastructure, as well as biennial regional events in Asia and Africa. In fact, the last conference she was organized in Delhi, it was in 1992, and it's very high time. So I now request Mrs. Alison Bartle to present her speech, and thereafter we'll have a question answer. Mr. Bartle, please.
Convey my deepest sympathy to everyone in India who's been affected in any way by the latest tragic wave of the COVID pandemic, especially those who've lost loved ones or colleagues. As in so many other nations, there have been some awful waves and peaks in the battle against this virus, and I do sincerely hope that this latest wave will pass by soon in your country, so things can get back to normal and we can meet together. It certainly would have been a very great pleasure to be with you personally today. I feel incredibly honoured to be addressing you today to deliver this second Professor O.D. Thapar Endowed lecture, and at such a globally renowned institute as Roorkee. It was founded in 1847, making it the oldest scientific and technical institution in the country. And although I wasn't around in 1847, I've been full of admiration for your research work over so many years. And in my role as a publisher, I've had the pleasure to publish papers from the Institute since the beginning of my career, way back in the 1970s. Of your 22 departments today, I notice that at least half can be directly associated with the study, planning, and development of hydropower. And I know that IIT has always been at the leading edge of hydro and especially small hydro research. My lecture today is probably very different to those which many of you people studying here may be used to, in that I'm not intending to show you one single equation. My aim is to put your work into the broader context of the global role of hydropower, past, present and future, demonstrating its multiple benefits for society, and thus to underline the importance of the career pathway that you've chosen. In tracing developments in hydro, from its early role in economic development to its crucial role in the coming years, as countries transition towards carbon-free economies, the talk will take us on a journey with some ups and downs regarding opinion on hydro, but its unfaltering role in meeting many needs of society, which I think underline its unique characteristic in the energy mix. So to start with a bit of history, when comparing various forms of energy, particularly renewable energy, a key feature of hydropower is, of course, the maturity of its technology. That's not to say the industry is not dynamic today, because there are certainly plenty of developments and refinements in efficiency, but these are based on very firm foundations. Early hydro schemes date back to the 19th century, and the first large-scale developments linked with industrial development were built in the middle of the 20th century. I'm sure you're all aware that India was one of the pioneering countries for hydro development, along with the UK and USA, and the Hydropower hydro plant in the foothills of the Ariati estate near Darjeeling was commissioned in November 1897, making it the first hydro plant in Asia. With an original capacity of just 130 kilowatts, it was uprated to a megawatt in 1916, and after a repair to landslide damage in the 1980s, it was still operating to celebrate its 100th anniversary in 1997. So just to take a quick look at some early hydro developments elsewhere in the world, This enormous Snowy Mountains complex in Australia was constructed between 1949 and 74 and was the largest infrastructure scheme in Australia. It had 16 dams, or has 16 dams, 9 power stations and 2 pumping stations, and provided peak power for 3 states and 2,100 gigalitres of water for irrigated agriculture. Construction began on the Hoover Dam in the USA in 1931, and during the Great Depression in the USA, it provided employment for thousands of workers, as well as, of course, irrigation water, hydropower, flood protection, and a water transfer system across several states. It provides electricity to 1.3 million people and was instrumental in the development of major cities in 3 or 4 states of the southwest USA. And then Aswan Dam in Egypt, built in the 60s, it played a pivotal role in Egypt's industrial development, economy, and culture. As well as hydro, it provided flood control and urgently needed irrigation water supplies. It actually saved the country from 9 consecutive years of drought and from devastating floods in 1975 and 88. And then Grande Essence in Switzerland, built between 1951 and 61. It had a workforce of about 3,000 people working at high altitude, and it exploits the runoff from 35 glaciers. Today, it's still the world's highest gravity dam, and it's part of a major hydro and pump storage complex. But originally, its purpose was to develop Swiss industry after the Second World War. And then Bakrabis, closer to home for you, which went ahead in 1947, was another early major feat of engineering with multiple and massive benefits, bringing socio-economic uplift to a very large region. Apart from irrigation water for 3 states and hydropower, the scheme provided effective flood control over thousands of hectares of land. And we know today there are visitor centres and wildlife and bird sanctuaries that can be visited by the public. Now, a message which really underpins this talk is the fact that hydropower stands out compared with all other forms of energy, including renewable energy, in that it's the only source which can offer such a range of major additional benefits, multi-purpose benefits. If a storage scheme's involved, it can, of course, produce not only water for domestic consumption, irrigation water for agriculture, food security, but also we mustn't forget that it plays a vital role in grid stability in view of the increasing use of intermittent renewable energies. And today, reservoirs offer fantastic opportunities for hybrid schemes, which is something I'll come back to later. I just want to give 2 examples now of outstanding regional projects which have offered a lot of these multi-purpose benefits in different parts of the world. The first is the Meroe scheme in North Sudan, a multi-purpose development producing 1,250 megawatts of hydro, commissioned in 2010. As well as more than doubling the country's installed capacity and allowing for the creation of a new high voltage transmission network linking to several major load centres in the country, it will provide irrigation water for an area of about 400,000 hectares. Farmers associations have been formed to encourage new agricultural techniques, and an example which you can see illustrated here is the cultivation of seed potatoes. They can now be kept at the correct temperature during their cultivation and storage, which wasn't possible before. And they're so good that they're able to be exported, which is another revenue source for the country, of course. The resettlement plan has incorporated the construction of hospitals, clinics, all with very modern facilities, mosques and schools. And those resettled from the reservoir are receiving water and electricity for the first time. One of the major benefits was also the creation of roads between Meroe and the capital. Previously, it took 9 hours to travel between those cities, by camel, by road, on foot. And of course, that was a major challenge for anybody ill or pregnant women to try to reach the major cities. The next example is the GAP, the Southeast Anatolia project in Turkey, a classic example of regional development with 22 2 major dams spread out over a large area, huge amount of irrigated area, 17,000 square kilometres, on an area which was previously a vast arid desert. New crops have been introduced again, guidance centres to encourage investors, training in animal husbandry, special women's centres, which was very important in that region, so they could develop computer skills and handicrafts to develop cottage industries. Also, it was a little bit controversial that a city, which was actually a derelict city, had to be flooded for the project. But international students have been working on the restoration of mosaics, frescoes, and artifacts which had been neglected before the project and now will be preserved as part of the cultural heritage of the region. A word about what run-of-river projects can offer. Hydropower has also led to the taming and controlling of stretches of some of the world's major waterways, which otherwise would have been wild and not navigable. So that's provided the opportunity for a lot of economic benefits there. And there are a few examples here in the Americas, Asia, and Europe. Work began in the 1930s on the Columbia River, where hydropower was developed very much hand in hand with navigation potential. So power demand in the Western USA, which had tripled in the 1940s, could be met, and large-scale locks were combined so that big vessels could pass through, big barges, which were used to transport agriculture products, wood, and petroleum products to neighbouring countries. In China, a major scheme called Jiangxi Shihutang Navigation and Hydropower Complex was also designed to improve the use for freight transport of that river, but also hand in hand with hydropower development. A huge additional benefit was flood protection in a very vulnerable area. A major stretch of that river has now been upgraded for 1,000-ton vehicles, and it's estimated that 220,000 tons of CO2 emissions are saved by the hydropower. On the Douro in Spain and Portugal, a total of 15 dams and hydro plants have been built on a 900-kilometre long stretch to regulate what were formerly quite turbulent stretches of the river, to generate hydropower, and to allow large shipping to pass through navigation locks. 5 dams are within Spain, 5 on the border, and the other 5 in Portugal. The Douro is especially important for the transport of agricultural produce, of course the famous port wine, and also for touristic boats in the region. Moving to Romania and Serbia, the JAD 1 and 2, also known as Iron Gates Hydropower and Navigation System, is one of the largest such schemes in Europe. It exploited significant hydro potential and highly improved the conditions for navigation in what was formerly a very dangerous stretch of the river on the border of the two countries. It's fulfilled its intended purpose and produces 13 terawatt hours a year of electricity for the two countries. And finally, Rio Madeira in Brazil and Bolivia, a major ongoing scheme, which is part of an initiative to integrate regional infrastructure in South America. The aim is to integrate highway networks, rivers, hydro dams and telecommunications throughout the continent to allow for greater trade and ultimately a South American community of nations. Shown here is the Girau project, just one of the 4 schemes with 3,300 megawatts of hydro. This is regarded as the cornerstone of the Brazil, Bolivia, Peru hub of the initiative to integrate those countries. And now on a little bit to public opinion. Despite all the good things that I've said about hydropower and dams, there has been opposition. It's been, public awareness has fluctuated a lot. I'm glad to say it's going very much better today. But during the 80s and 90s, this is the kind of thing we could see. And I think one of the main reasons was that some of the dams originally built, as I've mentioned, for industrial development, were built at a time when there was simply not enough knowledge about environmental impacts. And social aspects maybe weren't appreciated as much as they should be. So there were cases where large developments transmitted power to large centres, but maybe the villages close by were not so well off. And there were also issues around resettlement, of course, as I'm sure you know. It was a controversy in areas where people locally weren't immediately compensated or benefiting from the dam immediately. So this was the situation in the 90s. It culminated in a report by the World Commission on Dams, which tended to group together all projects as if they were very similar, including very historical ones, and some political NGOs seemed better at communicating than the engineering community. It was ironic that most of those were based in very comfortable countries like Switzerland, UK, and USA, where they benefited from heating, from cooling, and of course clean water supplies. But just after the World Commission on Dams report, there was a good turning point at the beginning of the century, led very much by the World Bank teams, and you see some of those people involved here. The World Bank re-examined its perspective on water infrastructure, and in 2002 launched its water resources sector strategy, which re-endorsed the development of water infrastructure, and then following that, directions in hydropower the following year, which reaffirmed the bank's commitment to supporting these kinds of developments. Professional associations like ICOLD and IHA played a role, as well as the technical media like ourselves, the United Nations, and a lot of governments. And then efforts were made to present a much more balanced view of the benefits, and a lot more had been learnt about what you do to mitigate the unfortunate aspects. And a number of things led to public acceptance eventually. A major factor, I would say, was communication, clear and precise communication to local stakeholders, either through dialogue, as you see here, with clear explanations about the project, what it's for and how it will be built, involving people in decisions where it might be possible, like giving them a say in how they design buildings or village layouts. It may not cost more to let them decide, and then they obviously are proud of the developments because they help to initiate them. Websites dedicated to projects is another very wise thing, and it's taking off more and more because then there's full public access to exactly what's going on, some for engineering purposes, but also for lay people. Through these dialogues, better assessments could be made of local needs so that assumptions aren't made on behalf of people. And then improved livelihoods are, of course, the most important way to have some harmony with the communities around the projects. So this is really the human side of a technical development. Agricultural techniques, new housing, which is improved, schools, the development of fisheries, and these sorts of things. Another factor in making everybody really appreciate renewable energy and particularly clean hydropower were, of course, concerns about air quality from fossil fuel generation, and then climate change impacts, the ones we know about and the ones we anticipate, which could lead to more extreme climatic conditions and can certainly be alleviated by having a cleaner planet. Flood control is also another thing. More attention is also paid today to improving the aesthetics of and around dams and power plants, encouraging recreation and tourism, and maybe visiting wildlife or bird sanctuaries such as at Bakra Bees. So people can enjoy these man-made water bodies for boating, fishing, trekking, and of course the Swiss occasionally like to ski down their dam faces. The launching of the United Nations Sustainable Development Goals in 2015 was another major endorsement of the value of hydropower. I'm not going to read all these because they're quite obvious, the links between the goals and hydro, but just to emphasize that 8 of these goals can be addressed by hydroelectric power. Reduction in poverty, reduction in hunger, enhancement of health and well-being, clean water, obviously, clean and affordable energy, encouraging industry, for example, in remote areas, hydropower can do that. Its role in climate change mitigation, And then finally, partnerships, and I think that's an important one to dwell a little bit more on. So just to look at, for example, international waterways and cross-border collaboration as a way in which hydropower can really bring countries together and avoid conflicts with careful dialogue, careful data sharing, joint studies and planning, the establishment of treaties, which is very important, and then working together on safety and environmental aspects. Here are just 3 examples of shared joint developments of major waterways. In West Africa, the Senegal River being jointly developed by Mali, Senegal, Guinea and Mauritania. And you see some examples of the projects here. And that's under the auspices of OMVS, the regional organisation for development of that river. The Mekong, of course, is a very rich source of hydro potential, particularly the lower Mekong. And the Mekong River Commission does a very good job in bringing together experts from all those riparian countries, and also closely working with the Lancang Mekong Cooperation Organization in China to work on joint planning, avoiding conflict, sharing studies, and looking also at aspects like environment and climate. Rio Madeira, I already mentioned, in Brazil and Bolivia, so another example in Latin America of the joint development of one waterway. And then international collaboration, I'd say, is especially important in this time when there are major concerns about the impacts of climate change as a result, for example, glacier melt, and then extreme climatic conditions, droughts, floods, landslides, and all of this. So it really underlines the need for collaboration in modelling, assessing risk of hazards such as landslides. We know, of course, there was the tragic accident in northern India recently when a landslide collapsed onto a glacier and caused the destruction of a hydro plant. In other areas, Himalayan regions particularly, there can be an upstream hazard that would impact on downstream countries. So absolutely essential to work together, because rivers are not going to, or waterways are not going to recognise boundaries. So the riparian countries need to work together. And then mitigation measures can be implemented jointly. And then the other form of collaboration to come on to is, of course, power trading, in which India is very much involved with Bhutan, and more recently agreements being reached with Nepal. So you see here agreements between Bhutan and India, Bhutan having a vast hydro potential with only 5% being developed. In 2010, as one example, 82% of its generation was exported to India, and then electricity sales accounted for 20% of Bhutan's GDP. And then looking at Thailand and Laos, a similar situation, that Laos, being very well endowed with hydro potential, is developing and exporting to Thailand. Thailand also importing from Cambodia and Vietnam. A very satisfactory agreement between all the countries that can manage to do this, because for the less developed neighbours who have vast potential, they can have a chance, of course, to boost their economies, while the power exports are helping to meet the needs, the growing demand in the more developed countries with rapidly increasing industrialisation. And next, just coming to environmental aspects of hydropower, very important, and relating a little bit to what I talked about before, the increasing knowledge and therefore a greater acceptance of hydropower. In my lifetime working in this profession, I've seen massive changes over the years, increasing knowledge and experience of environmental issues, and issues which may have varying significance in different parts of the world. A problem in Burkina Faso might be not quite the same as one in the United States, but all of them are important in their different ways. I recall a time when there was no great conversation about the environment, and today, on the other hand, there's probably no engineering company without environmental experts or a dedicated environmental department focusing on ecology, on environment, on environmental impact assessments, and on mitigation measures. And the international finance agencies, of course, have a very major role to play. They've helped greatly in studies and in developing protocols and guidelines. And they're in a very good position to do that and to recommend their use because they're holding the purse strings to finance the projects. So that's been very important. Technical developments have emerged alongside. The industry has also stepped up. As we all know, a very big issue today is fish protection, and there have been all sorts of innovations in that field in terms of civil works and also hydraulic machinery. And then in hydraulic machinery, for example, the reduced use of oil in bearings and all of these things, those are just several examples. And you people in Roorkee are probably studying a great deal more. And now, importantly, the role of hydro today, after dealing with a lot of its history and its journey to where it's come, this is based on data from our annual atlas of hydropower and dams. And from that, we can see that world hydro capacity in operation has reached 1,230 gigawatts. And under construction is a further 125 gigawatts. And here you have the production figure for 2020, 4,313 terawatt hours. And we know that hydro is going on in at least 162 countries. Those are the ones we know about. And more than 50% of those projects are multi-purpose developments. And new schemes are going on probably in more than 120 countries. That just shows what we have knowledge of. Hydro contributes around, it always fluctuates between 16, 17, 18% of world electricity. It doesn't sound a huge figure. And it could never supply all the power needs of the world. So it must work in synergy, preferably with other renewables. But the important thing to say is that where hydro resources are available, it seems to me that they should be prioritised. And now, of course, hydro's role in working in synergy with other renewables will increase its importance even more. Today, it does supply more than 70% of renewable energy. I also think it's worth having a quick look at the contribution increase in hydropower over the last 15 years. Sometimes it's steady, sometimes it's dramatic, but it has always been an increase. And without going through all of this data, which you could look at later in the paper, it's interesting to see the least developed of the continents where the need is greatest, there has been a very healthy increase over the last 15 years. 60 or 61% in terms of production and capacity being implemented. That is concentrated really in 3 or 4 main countries, which I'll come to in a minute, but it's a very healthy increase. And of course, there are regional schemes going on to benefit more than one country. Asia, of course, is tremendous, and China and India are among the leaders there. So this is a phenomenal increase in capacity over 15 years and also in production. South America's steady on. Some of the larger schemes are slowing down, but nevertheless an increase. Europe passed its heyday some years ago, but there is at least, quite surprising actually, quite a bit still under construction. We'll look at that in a minute, and also a lot of refurbishment, but not so much new development. And there you see the world increases at the bottom. And I now thought it might be good to go very briefly, without reading or discussing all this data, around the main continents with activities going on. So don't attempt to absorb all this. But I think the main thing is the installed capacities I showed you just now, the hydropower under construction, and the percentage which has been developed already, which shows the huge remaining potential. And in Africa here, a very important part of the world for advancing its hydro development, it's making great progress. They're beginning with solar PV, large regional schemes, as I said, and then small hydro, very importantly. I will say a bit about that in a minute, but there we are with over 10,000 megawatts. As I mentioned, most of the big developments are concentrated in Ethiopia, Cameroon, Uganda, Angola, and more recently Tanzania. Moving to Asia, it's already been mentioned that the hydro capacity is enormous, and also 88 gigawatts under construction, and yet still only 27% of hydro potential has been developed, so plenty more to go, and we can see that a lot is planned in around 37 countries. Floating solar PV plants, that's a very big area of interest right now in Asia, with big schemes in China, Japan. There's India, Indonesia, and Vietnam. And Omkareshwar in India, when it is constructed, will be the largest at 600 megawatts. I already mentioned cross-border schemes, the importance of those, and it's important to say that while big developments are underway in the countries I mentioned at the bottom here, there are small hydro programs going on in virtually every Asian country. Latin America is still a modest amount going on. Some of the huge projects are already developed. Quite a lot, like more than 8,000 megawatts under construction, and then plenty more planned over 9 countries. And the leading ones right now being Argentina, which has picked up with a lot of binational projects with Paraguay, Uruguay, Bolivia, Chile, Colombia, and Peru. Also floating solar in Brazil, so combining hydropower and solar. And then a big small hydro potential once again. And then Europe, as I say, it's not quite such a large amount of new development, so less than 4,000 megawatts. But of course, we have substantial capacity installed in Europe, and some of the best sites, of course, or a lot of the best sites exploited some time ago. There is, in fact, 50% of potential remaining. That could be mainly through refurbishment. But what the main activity right now in Europe is pump storage, adding it, upgrading it, embarking on it for the first time. And there are also floating solar PV schemes in quite a few European countries. And finally, Australasia, Oceania, which traditionally doesn't have a huge amount going on, but the big thing at the moment, as I'm sure you know, is the major Snowy 2 pump storage in Australia. So the next stage of what I showed at the very beginning, the iconic Snowy Mountain scheme, now upgrading with new developments and a 2 gigawatt pump storage scheme. There are also small hydro schemes going on around the islands of Oceania, and for example, Fiji, Papua New Guinea, New Caledonia, and the Solomon Islands. Just a special word about small hydro, where you have a lot of expertise at your institute already, so I don't need to tell you too much about it. The world capacity could soon reach 100 gigawatts, according to UNIDO studies. China alone, with 45,000 small plants, totaling 59 gigawatts. And then the vast potential I showed just now in Asia, Africa, and Latin America, quite a bit in the UK too. Here are a few points to recall on the special attributes of small-scale hydro. Of course, it can be simple and low cost in terms of technology, so very easily adaptable to rural communities. And that's so important when more than 1 billion people in those areas lack an electricity supply. It can also be retrofitted at existing civil works, and that's going on more and more in the United States, for example, and in Europe. And there's been a lot of innovation in the industry, for example, in terms of new ultra-low head turbines, which can lead to some more innovative applications. 66% of world small hydro potential is untapped, according to the latest global overview report from UNIDO and the International Centre for Small Hydropower in China. Global installed hydro capacity is estimated at around 78,000 megawatts, more than 60,000 megawatts of which is in Asia, and that is only less than 40% of Asia's potential. Within Asia, a huge potential especially remains in India, Bhutan, Nepal, Indonesia, Vietnam, China, Kazakhstan, and Japan. And of course, there is also a vast potential throughout the world, and most countries have development programs ongoing or planned. And now just to some ongoing challenges. Life would be very boring without those. And I think one could summarize, I mean, there are plenty of challenges, as anyone implementing hydropower would definitely say, but I would say today, if you had to pinpoint the major focus of attention, it would be remote sites, dealing with more and more remote sites, because of course the more favourable ones are developed already. Natural hazards, which I mentioned earlier, landslides, earthquakes. You see here the Wenchuan in the top right, the Wenchuan earthquake of 2008. So natural hazards, but also man-made hazards. And that image on the bottom left, of course, is cybersecurity, which is keeping everybody on their toes today in power plants as well as in many other sectors of industry. I didn't show here, but another big challenge worldwide is succession planning. The audience today will ensure that research and technical developments are in very good hands for the future. And those of you who are studying at this institute will be stepping into the shoes of world-renowned experts in all the various disciplines relating to hydro. But it does remain a problem, and many countries are expressing this, that some of the top experts are quite mature now, and it's imperative to encourage young engineers into the profession, and particularly also in countries where there may not be so many hydro activities going on, and also to pass on expertise from one generation to the next. Another special word, because I mentioned earlier the importance of this, is hydro working in synergy. This is not a challenge, obviously, but an advantage. One of the most important emerging technologies, of course, as we transition to carbon-free economies, and it's the perfect partnership, hydro and solar. The US Department of Energy has published a report predicting that theoretically it could provide about 40% of world electricity if it were fully exploited. Of course, huge advantages are saving on land use. It can be installed obviously over larger areas or in countries with high population density. And in fact, one of the first schemes, possibly the first scheme, was in Singapore. The solar panels can help reduce evaporation on reservoirs, and also there is less shadow on the panels themselves than would be the case in heavily built up cities. So these schemes have been emerging in the past 7 or 8 years, but now developments are accelerating. India, of course, was one of the earliest developers, along with China, Korea, and today there are reported to be installations in about 60 countries. And my company, Aqua Media, is going to be working in conjunction with one of the technical committees of ICOLD, the one on emerging challenges and solutions, in organising an online conference on a virtual conference on floating solar panels on hydro reservoirs. That will be on the 7th and 8th of July, and we'll be publicising that a lot in the coming days. The other special concern to accelerate development right now is pump storage. And just about everywhere in the world, it's astonishing to see how many of these schemes are taking off. Its importance is evident with the increasing use of intermittent renewables. Large developments are still underway in China, Korea, Japan, India, and the USA, and also upgrades to some of the original projects. A lot of upgrading and extension of projects in Europe, Austria, France, Switzerland, Portugal, Germany. Also Iran has plenty of pump storage, impressive developments. New developments in the last few years in Israel and in the Philippines. And then plans for schemes in Scotland. And then some new developments planned in Kenya and in the USA. A very exciting new development that we just wrote about in our last issue is the first underground pumped hydro scheme planned for development in Estonia. Those schemes have been planned for many years, probably 15 years, and have been considered in the USA and Netherlands because, of course, they're suitable for flat countries without the usual topography for pumped storage. Estonia is going ahead and doing it. And there's a 500 megawatt scheme planned, and as I say, you can read more about that in the latest issue of Hydropower and Dams. And now, moving towards a conclusion, the future role of hydropower as we move on in the pandemic recovery period and in the coming years with climate concerns and everything else. I would say the pandemic has encouraged organisations influencing power policy to look ahead to this recovery period. Economies need to recover and the world needs to recover. And there's been a strong consensus on the role of renewables, particularly the crucial role of hydropower, not only in its own right, but also, as mentioned, to work with other renewables. Of course, that avoids fuel costs. And there's a very strong future, which has been declared recently by the African Union and the International Renewable Energy Agency. They've pledged to work together on renewable energy resources in Africa as a key strategy in recovering from the pandemic. And then IRENA, in a recent report, their high-level dialogue, has called for world hydro capacity to increase by 60% by 2050 and for pumped storage to triple, and that's the Energy Transformation Report of 2050. According to the International Energy Agency and its World Energy Outlook last year, by 2030, hydro, wind, solar, and geothermal, bioenergy and marine could provide nearly 40% of electricity supply. So global uncertainties currently have really made everyone stop and think more about the future of the planet, about not taking things for granted, and being more proactive in determining best practice for a sustainable future. And that brings really to my last but one slide actually, to say that in an age when it's possible to store 16 terabytes of data on a very small gadget that you see bottom left there, measure seismic activity on Mars, and to achieve all kinds of things with artificial intelligence and robotics, and actually I have shown an equation here, which I promise not to. But in this time of these massive scientific and technical developments, also in the medical field, 1.1 billion people in the developing world still lack an electricity supply. And those are mainly in rural areas of Africa, Asia, and probably Central America too. So children are forced to do their homework under streetlights. So a lot of work lies ahead. And to help undertake that, you people who are studying in the field of hydropower and renewable energy have chosen a really excellent and rewarding career path. And I'd like to end by wishing you all the very, very best in that. So thank you once again for inviting me to give this lecture. It has been an absolute honour, and I hope that that helps to put some of your work into the global and the human perspective of the benefits of hydropower. Thank you very much.
Thank you, Mrs. Alison Bartle, for your such a wide subject covering, which is not only hydropower but solar and pump storage and the total canvas of the electricity which you have illustrated today, and especially the backdrop of intermittency of renewable energy. So we now request that some question answer are there in the chat box. For your convenience, I would like to read for them, but if you like to say something more, you are welcome to do so. Mrs. Alison, please. Mrs. Alison, we can't hear you.
Sorry about that. Thank you so much. First of all, I'm very sorry for a slightly late appearance on screen because of some technical issues with the Macintosh, which is very great for publishing, but sometimes not so good for being immediately compatible. Anyway, I would like to say again what a great honour it is to be here with you, and I'm sorry that it's not personally being here with you because of the global situation, and maybe sorry to have bombarded you with a lot of global information. But I saw somebody asking about receiving the talk and the written paper, and certainly I understand that you'll be circulating it. So that's fine, and it would be great to continue with some discussion if anybody would like to do that.
Mr. Alison, there were two questions. One question has been asked by Mr. Ashwani Kumar, who has been the Managing Director of Solar Corporation of India. He said that in the coastal areas, How about the pump storage, the coastal area where cheaper RE could be very much combined? So what stops it that people are not exploiting it? Especially when you have the coastal area, you have the water as well as the good other RE like wind and solar.
Yeah, it's a very good point, and I would say that as far as I am aware, that these sorts of developments are beginning. I know that the French have done a lot of research on that, and also in Japan there have been cases. I think maybe things are going ahead a little slowly, as can often be the case. In the past few years, it's been so critical with accelerating wind and solar to think about storage, and so this will certainly be an upcoming trend. I'm quite sure about that, because the conditions are of course just right in solar areas for hybrid, including wind and solar as well as solar, which I mentioned. So this will be an exciting thing to look for. I know Mr. Lampérière of France has done some work, and we've published some papers on this subject, which I could put anyone in touch with. Storage is an issue, I should have said. I mean, pump storage seems the main and the most important and the most major one that we are all involved in. Of course, there is also research ongoing on battery research and the relative merits of battery versus pump storage. And as far as I have learnt so far, the battery applications may be more appropriate when there are smaller amounts of power to be stored. And I think pump storage will always be the main thing that people will look for in the coming years, as is happening already, as I mentioned, to go together with intermittent, the new so-called new renewables that are taking off at such tremendous speed around the world. Everybody's racing to meet their renewable energy targets.
Now, another question has been posed by Dr. R.P. Singh from Vienna. And he said that you being the Wikipedia of hydropower development, he has a quest to learn from your views that in respect to the climate change and need of resource efficiency and circular economy, the longevity, because hydropower is 100-year kind of longevity of hydropower, which is one of the very important area to focus on. So what do you think that a framework or a policy framework, exploration on the circularity, compliance to the hydropower system could be evolved so that this hydropower with a long term renewable energy stays?
Yeah, I think first of all, the longevity of hydro is sometimes underestimated or not focused on enough when people speak about the high initial costs. That was the first thing I meant to stress, that people worry a little bit that this is a very let's say risky investment in hydro because it initially seems expensive. But what I tried to show in this paper is these side benefits. And although there's been work on quantifying those, I don't think really anybody has totally succeeded in looking at the economic benefits of all the side effects. So that's one thing about the efficiency of hydro. And I'd say the efficiency, it's kind of inherently good for sustainability and the new concepts on circular economy, because it is relieving pressure on other resources, which is one important criterion. And also another point I didn't mention in the PowerPoint is that in a way its efficiency has scope to increase even further with the increasing use of artificial intelligence, for example, BIM modeling. All of this is saving costs, I would say. Even robotics on sites. I mean, one will never replace engineers on sites, clearly, and it wouldn't be the right thing. But we had a paper recently at our Hydro 2020 conference on how a scheme had reached construction in Switzerland with absolutely no paperwork. So I would say that the inherent characteristics, clearly, from the climate change point of view, there are the clean aspects, the renewable aspects, but the inherent efficiency and the scope for continuing efficiency through all the new developments that are now possible with greater computer capacity can only make it a more and more efficient source of power. Okay, it takes a long time to build. Civil works may be expensive, but once you've got those works in place, there are so many other benefits for society than just electricity. And that really has to be stressed all the time about hydropower, when particularly some NGOs may reject it as big civil engineering and only for electricity.
One question came from the student. He says that the reservoirs are producing GHG. So when you cover with the solar panel, will it increase the GHG? Are there some guidelines for defining the method to control or use this GHG for some useful purpose? So that kind of question came.
Yeah, that's a very, very interesting point. And I would say because there is existing extensive research, particularly in Brazil and Canada, on emissions, this will be an emerging topic. And as far as I'm aware so far, I'm not really an expert yet on floating solar, well, yet or at all on floating solar. And this is the reason we're actually holding a conference very shortly, as I mentioned, where we will look at all the challenges that one doesn't necessarily know in advance about floating solar. And we will have environmental experts specifically taking part in that. So we will not only talk about potential and case studies, but as it's a relatively new technology, it's possibly a little bit early to say, because some of the installations have been on a reasonably small scale and maybe in areas where this wouldn't be quite such an issue. But I would say, if you ask me again in July, I hope to know a lot more about specifically studies going on. But clearly, that's a very, very important need for research. And I think it will come out in the July conference.
One question is very interesting. At least I found a very nice question. Climate change impact is happening. Somehow, while people do the hydropower feasibility studies, they do not study the climate change much. In fact, they do a EIA, they do a past data of the hydrology. So what kind of things you think that the hydropower studies should carry it out, and how they carry it out like this? So that's the question. Does it impact even a small hydro?
Well, certainly there is research going on, and actually the World Bank, I know, has done a lot on hydrological risk. There's some very good experts at the bank. I know Pravin is somewhere here in the audience, and he would also be able to vouch for how much work has been done. We are beginning to have sessions on that, which does seem to reflect that there is a lot going on in research institutes on trying to forecast, sometimes taking specific projects and analysing what is likely to be happening in the light of climate change, looking at structural implications. I mean, for example, the very obvious one is upgrading spillways, where there could be increased flooding, but not only such things, looking at inflow to reservoirs, looking at extreme climatic events on both ends of the scale. So we've published quite a lot. We have had good conference sessions specifically on that. Again, it's something emerging, I guess, but when we research for our annual publication, the Hydropower and Dams World Atlas and Industry Guide, we are now asking in our world survey, what is your country doing? On one level, what research is going on, but also are there guidelines now in place? And of course, it's a different answer from different parts of the world, as you'd expect. But certainly, I mean, the Swiss are doing research. There are definitely a lot of climate modelling going on. I guess also at IIT, I would imagine.
Yeah. We have a question for Professor Hang Liu from, originally from China, but I think he's now UN. One of the challenges for the small hydro development in the developing country is the risk of financing. Do you have any suggestion on de-risking of financing for developing a small hydro, especially some of the African countries and other places, which is so do you think there's some suggestion for de-risking of the finance?
I totally agree that it's essential to look at innovative financing models for the developing world. It's clear it's where there's the greatest need and the greatest potential. And of course, there are aid agencies who are working with technical assistance and funding, which must help a lot. As I mentioned earlier, of course, small hydro, particularly in the context of developing countries, can be designed to be relatively simple, relatively low cost. But the fact remains that there needs to be assistance, clearly. I know I'm involved actually at the moment on the HYPOSO scheme, which is a European Union scheme jointly with Africa and specifically focusing on small hydro in Latin America and in Africa. And that is supposed to be a venture to bring together, to encourage, of course, European funding, but also European exchange of experience. So I think more and more projects are springing up like that. So there can be, I think really essential is not just funding, but technology transfer. And when you see this happening, at least if the initial schemes may cost, stretch budgets a little bit, at least the carry on for operation and maintenance and new projects might be more easily managed, one would hope.
Okay, I think thank you very much. If I don't see any other question, but I would like to put one question from my side. As we know that you are a publisher, which is the most reputed journal in anybody, especially the practicing engineers, industry, international hydropower and dams. I would like to request or suggest that, first of all, in India, hydropower, though we have started with a big bang in 1897, till 70s, 80s, we did a lot of things. We also have a lot of projects in pipeline, but things are not coming in that way. So perhaps some kind of international focus or some kind of a, advisory role as an editor of such a big house and could play upon maybe making a big event in India so that Indian policymakers are awakened on this particular, because we have a large RE coming. RE nobody can stop, and there's also because decarbonization is happening, but somehow because hydropower takes time, so this is high time that you may like to think of that you waking up by some kind of a big event happening in India, so that policymaker, that's number one. Somehow the education institutes are not much of get benefits of your this journal. The reason the journal today, the journals are mostly online, whether you subscribe or not subscribe, because there are two types of things. So I would request that no, of course we are from hydro industry, we are the hydro department, so we subscribe physically also. But today the time when electronics has come, and then where a lot of people go into search in that series, what kind of suggestion you like to have some corner for the academic institution also, because academics also a big play, they also play a big role in the, though academic they cannot get the money in terms of survival, because the survival comes from the industry, but in terms of a section of the hydro, because we as a education, as a research organization, would like to that this kind of, what kind of role you think that job opportunity for hydropower, what you look, could throw light on that, please.
Okay, well, first of all, about events, we certainly, and back in my former life on a different publication, we did actually bring a small hydro conference to India. The only reason we hesitated after that to bring them is that conferences on hydro have seemed to be fairly prolific on hydroelectric power. Both CBIP and also Mr. Varma used to organise, CVG Varma, the ex-president of ICOLD, annual conferences. And actually, I would always attend. I used to be about once a year or so, and we would have a session on things like capacity building, public awareness, and all of those issues. So we've contributed a lot to existing conferences within India, and actually not wanting to compete, as there seemed to be a lot going on. But we can certainly think of that in the future. We can also think about regional sessions within our existing international conferences, the ones we do in the autumn based in Europe. And then also every 2 years we do one in Asia, where we're committed now to be in Malaysia, which got postponed actually a total of 3 times. So our 4th date's in March next year. But we could certainly, I mean, we want to encourage more and more Indian participants there. And we can speak, we often speak about potential things that are hampering hydropower, hydro in the generation mix, which I know has fluctuated a lot in India. I remember a time when hydro was something like 40%. And I think that every country wants to diversify its energy sources, which is, a good principle. But now, okay, it's swung rather much the other way to a lot of thermal in India, but we see from our surveys that there are very ambitious plans right now. And I think it's quite ambitious and quite a formidable task, but the planned hydro and pump storage, large and small, is quite ambitious in India. And I know that you have big development goals for your renewable energy resources generally, and also hydro in the coming years. So I'm sure a shift will follow. And because you're racing ahead with the intermittent renewables, then pump storage and hydro will follow. But there already seems a lot under construction. And you have this vast long-term experience, but also in India, it's great that you have a new generation, and IIT is certainly playing a big role in that. You have interest among young people, which is not always the case. So you are leading in research, but you have a bright future in that respect too. As far as the journal's concerned, we would be more than happy. We have a controlled circulation. We have all sorts of things we've been discussing recently about facilitating reception of the journal within universities, research institutes, and it's something we can discuss later, of course, but we have a controlled circulation where we can make a lot of extra copies available if they're going through one address, one institute. So we can discuss that privately. I mean, the controlled circulation are complementary copies where they're most needed in the less developed and developing, so not only the less developed countries, and a certain amount are subsidized, free copies, by our AMI Hydropower Foundation, which is also helping people to come to our event. We would love to increase participation from India and have some keynote speakers at our events. We have the Asia one coming up in March, but before that, we really hope, if COVID is kind and finally starts to get the world back to normal, in October, it will be a totally international gathering, and we warmly welcome people from India, and we can certainly sponsor participation for some people. So we are all for spreading information. Our whole job is disseminating through all sorts of methods that we can.
Mrs. Alison, since a question has come from Ethiopia, I have time to pose it. A question has come from Ethiopia. The Grand Ethiopian Renaissance Dam is under construction, but is getting opposition from riparian countries, even though it is known that it has many advantages for sedimentation reduction through other countries. Any comment on this? That's one. And one comment has come from my colleague is there any cyber security has been started used in hydro plant infrastructure? So there are two different questions. One Renaissance Dam of the Ethiopia, another question came from my faculty colleague, that's a cyber security in hydropower plant. So there are two, and with this, that will be my last. Then I will hand over to our head. Yes, please.
Okay.
Go ahead.
So, of course, I'm aware of the dialogue in Ethiopia, and it's not unique. I mean, in different parts of the world. In the Middle East, there have been other disputes over the years. Of course, this happens. And I would stress again that the most sound thing that can be done is to encourage dialogue. And I know with Egypt, Sudan, and Ethiopia, ICOLD actually has tried to bring together a friendly dialogue. Within ICOLD, there is not conflict. There are international delegations. There are many transboundary projects discussed. And the best way to resolve these issues are certainly through a balanced dialogue, to go through all the aspects, and based on normally the solution to problems is through the existence of treaties, which I think I mentioned back at the beginning, like, you know, throughout time, the Columbia Water Treaty sorted out the USA and Canada, numerous ones since. And also I know that between India and Pakistan, there was the case of the Baglia Dam, and through going back to that treaty, re-examining what might have changed in terms of knowledge and experience over the years since that treaty, agreement could be reached quite amicably. I think that the views are very polarized, as far as I've been aware in the conversations I've had between Sudan, Egypt and Ethiopia. I've had sometimes some people from Egypt questioning dam safety aspects, which have been very well written about, and they're not in question. I know the shared waterway aspect is in question, but safety was not an issue. So there's a lack of understanding that, in my personal view, and I may be wrong, could be sorted out by the representatives of the three countries to sit together. And ICOLD has offered to host such a meeting. They actually asked also once if it could happen within one of our hydro meetings. It didn't happen so far, but I'm optimistic with a clear view from all sides, and if necessary, some new treaty about sharing those waterways may be necessary and eventually agreed, but it needs to calm and it needs information exchange. I was recently in an online symposium with people from the Mekong countries and the Chinese Mekong Lancang development country. I was so impressed by that. Every country in the Mekong MLC region and China were online sharing research and completely exchanging experience about what structural measures might be necessary for river regulation, and that's to the benefit of all of them to combat floods and so on. There can always be found some advantages as well as potential disadvantages, and it's a human thing to speak to each other and to try to reach some common ground and then to build on that. Sorry, you're muted. I can't hear. Sorry.
Yeah,
One question has been asked. One question has been asked is how the students get interested in hydropower, because somehow the hydropower jobs are getting reduced. So what kind of interest we should create in the students so that they get the interested to the hydropower profession? That's number one. And one, of course, one of the faculty colleague has said that are there guidelines available for environmental flows, which is becoming now environmental flows, e-flows, rather. So that's the question. I think that's all from my side. Otherwise, I will keep on reading the questions and I will stopping it.
Okay, to answer the last one first, I know the European Union has guidelines, and there's a water directive which sets out clearly standards. As far as I know, no global ones. I think it must be a regional or a national issue. I could be wrong, but as far as I know, I mean, I think regionally there are organisations that would be working on that, and then there would be case studies. On encouraging young people into the profession, it's something we've tried to take on board at some of our conferences with special sessions, and it's a very, very interesting question. There was a UK expert chairing a session once, and he put it very nicely. I mean, in the UK, of course, we don't have much hydro going on, only very, very small. But his perspective was that when a child, when he told a child he was an engineer, that child thought that he mended television sets and something like this. They had no idea that this would mean traveling across the world, designing large structures to impound water, to generate clean electricity. So things have to start at school level, I would say. In India, I know it was the case. I remember Mr. Varma being quite encouraging through the school curriculum to set competitions so that people, young children, are encouraged to analyse. They have to look up and research what actually are dams, what are hydro plants. So they grow up with some knowledge and experience, and they see the benefits as well as, I mean, to my horror, in some curricula, you can see negative impacts. I've seen this in, I think, in the British one school curriculum, that dams cause negative impacts in resettlement. And that's, of course, not a balanced view from the teaching profession. Then when people get older, what we found was quite nice at one conference, and it could be replicated, of course, anywhere, was to invite young engineers who joined some of the big consulting companies and were extremely happy in their jobs. We had someone from Tractebel, Angie Tractebel, from some other, I don't know, European, but not only, and African and maybe Asian countries, saying how they'd found their first year working in this country, how they'd travelled, what was beyond their expectations. Also to have a dialogue on what could the profession do to make the job more attractive. But I think it goes by case study, by, again, dialogue, by sharing information about what can be rewarding in that job, and to dedicate special sessions to that. You, of course, already in your institute have a lot of people who are keen on this profession. So you are instrumental in bringing in, as I mentioned, in bringing a new generation to maintain and further develop your hydropower. And that I mentioned succession planning as a big issue, because also for safety reasons, we have schemes which were designed so many years ago, and maybe the experts who were involved have already retired. Paperwork might not exist, or computer records might not exist. And so the next generation have to keep those structures, the water infrastructure, safe. And operation and maintenance is obviously a huge thing. And maybe not so exciting as building new things. So I think it has to be through the media. The general media, of course, are not so interested in those things, but through technical media, through conferences, through websites would be another thing. And maybe government websites could do something. And anywhere that's going to reach the young people who are deciding on their career paths, maybe some special talks in people who are about to leave school, or maybe graduate from their first degree in engineering and they're not quite sure what they're going to do. And it's obviously more critical in countries that have large water resources and the need for hydro and the need for water supply, irrigation, and all of those things.
Thank you, Professor Singhal.
Yeah, thank you very much, Mrs. Alison, for a very nice and informative lecture. And in fact, we had a very good interaction. And now already we have crossed the times. Otherwise, the subject is so vast and interesting that we could spend hours for such discussions. So now I request Professor Chaturvedi, Director IIT Roorkee, for his remarks on the event. Professor Chaturvedi, sir.
Yeah, thank you, Professor Singhal. First, let me thank Ms. Alison Bartle for having aptly made up for what was happening in the beginning. We were waiting for her, and somehow the technical glitches, we were feeling that we will miss her. But the fact that she could join, finally, we are so happy that she could make it. And it's also good to see that we had a recorded version of the lecture available, so that we could start the lecture and then she could actually handle the question answer sessions. Thank you, Ms. Bartle, for giving a very comprehensive lecture, very informative. I'm sure the entire audience, which is more than 130 people, are listening to this lecture. They have benefited immensely from your experience, from the vast experience you have, from the kind of depth that you have in multiple areas. And I'm reminded of the inaugural edition of this lecture. The inaugural lecture was also equally good. It was in the area of solar energy, and it was focusing more on the national scene. And you have given us an international flavor in the area of hydropower. And it is very enlightening to hear this. And it goes very well with the focus of the Department of Hydro and Renewable Energy, that we are able to cover different aspects of energy, whether it is hydro or whether it is renewable energy. We are very fortunate, actually extremely fortunate, that just like the inaugural lecture, today also we had Professor Thapar, who could join us in this online lecture. And not only that, it's very heartening to see that he has sat through the entire lecture. He sat through it from 4 p.m. onwards, and now it is 5:40 p.m. Thank you, Professor Thapar. We are indeed indebted to you. We are grateful to you, not only for the kind of service that you have put to hydropower, to IIT Roorkee, but also for your continued interest in such activities. And your life journey, your bio sketch itself is a inspiration for many of us, having started from Lahore to BHU, to going to Punjab State Electricity Board, and then coming to University of Roorkee, and then writing a book as late as 2013. I think that's an inspiration for so many of us. That is what we say, that University of Roorkee has produced so many inspiring heroes and leaders, that it is always good to have something in their honor, in their memory. And it's very apt that Hydro and Renewable Energy Department, the AHEC, chose you after whom they want to name this lecture series. Different departments have chosen different iconic figures. In some cases, they've gone for national figures, which are not necessarily related to the department. But in many cases, we have been able to identify people who have made a difference to University of Roorkee or to Thompson Engineering College or to the department, and their impact can be felt even now. And we can really see, I'm sure, that the seeds that you had sown, you must be very happy to see that the tree is becoming taller and taller, the girth of the tree is becoming wider and wider, and I think the happiest person must be Professor Thapar himself. I would also like to thank Dr. Rakesh Thapar and Dr. Vandana Thapar for having taken the initiative to fund this lecture series perpetually. We are grateful to them for that. This address of mine will not be complete unless I talk about the kind of trajectory that our hydro and renewable energy department is taking. I think they are just building on the strengths of AHEC and bringing at the same time, bringing new and new young blood, new areas, new focus, without losing their core strengths of the past. That is not an easy thing to do, but I can see that the people in the department are now a set of people who are very senior in age, and I think both of them are giving their best to be able to make sure that we build on the foundation that all the people like Professor Thapar and others have laid for this department. The fact that Professor Singhal, now you are 11, you should not be satisfied. You must be at least 20 before you can rightfully claim that your department is giving whatever is due in the area of renewable energy. Such an important topic, whether from the point of view of engineering, science, economics, regulatory issues, climate change, greenhouse gases. I mean, you have so much diversity, so much things to cover, and I think under one umbrella, if we can cover all these things, it will become a magnet to attract the best faculty candidates, best PhD students, best project sponsoring agencies to get the projects here. And I'm sure we are right on that journey. It is just that we have to keep on walking with the same dedication and the kind of perseverance that we had shown in the past. It's very, very matter of joy for me that some of these small things are taking very good shape across the institute in several departments. In fact, Professor Thapar, there are departments who have even beaten the HRE in terms of lecture series. So they have already had 4 editions, and Professor Singhal, I hope will quickly make up for it, and we'll quickly have more and more editions of this Professor Odi Thapar lecture series, so that we can have more distinguished speakers. And once Corona settles down, then I think the idea of this lecture series is to get people to spend time in the campus, get very distinguished people in the campus, let them spend time in the campus, let them visit the labs, let them meet our students, our faculty, let them know what good work is happening at IIT Roorkee, and at the same time, let them also offer advice and experience that we can benefit from. Well, this is not happening because of Corona, but at least if this is not happening, what good is happening is that we are getting an international audience, we are getting international speakers. So if we are losing out on something, we are gaining somewhere else. So good that it's happening. Congratulations to everyone. I think Professor Singhal, you have done a very good job in this organizing this event. Thank you very much.
Thank you, Professor Chaturvedi. We take your words and we are on the track for adding the faculty, and also we soon have another lecture also in this series. And now my colleague, Professor Himanshu Jain, will present the formal vote of thanks.
Thank you, Professor Sunil, sir, for giving me the opportunity to propose a vote of thanks for today's event. Professor Odi Thapar, Mrs Alison Bartle, Professor A.K. Chaturvedi, Director IIT Roorkee, Professor Sunil Singhal, Head Department Hydro and Renewable Energy, faculty colleagues, guests, students, ladies and gentlemen. It is indeed my pleasure to propose the vote of thanks today to Ms. Alison Bartle for delivering this very informative and valuable lecture on the role of hydropower in socio-economic development and sustainability in the future. We cannot thank her enough for taking time out of her busy schedule to deliver this lecture today. I would also like to thank Professor Thapar for gracing this event and staying with us for the entire duration of the event, realizing fully well that any amount of gratitude that we may express to him will not be enough for what he has done for this department and for ensuring its continued success. I will also like to thank Professor A.K. Chaturvedi, Director IIT Roorkee, who is the main guiding force for this event, and without whom we would not have been able to organize this lecture during these challenging times. Thanks are also due to Professor Sunil Singhal, our head of the Hydro and Renewable Energy Department, for taking the great interest in this Professor O.D. Thapar Endowed Lecture Program and ensuring its continued success year on year. Thanks are also due to the esteemed guests from IIT Roorkee and different organizations from across the world for participating in this event and making it a great success. I would also like to thank the authorities of the Institute who have extended full support for organizing this lecture and for the continuation of the Professor O.D. Thapar Endowed Lecture Program. I'm also thankful to the media and press for covering this event. And last but certainly not the least, I also want to thank my colleagues, staff, and students of the department who have cooperated wholeheartedly for arranging various activities to make it a successful event. So with that, I think we come to the end of today's program. And again, I wish to thank all of you. I wish you a great day ahead and stay safe, everyone. And hopefully next year, we would all be able to meet in person for another great lecture in this series. Thank you.
Right.
Thank you.
Thank you very much.